Hello guys. Today we're gonna do the comparison between TensorFlow and Pytorch library for deep learning modeling. As we all know, the Pytorch and TensorFlow are very popular libraries for deep learning modeling or artificial neural network modeling. So we're gonna do comparison of the TensorFlow and Pytorch. So for this project, our objectives are to compare the performance of neural network models implemented in TensorFlow library and Pytorch for the given problem. But the here problem is we have two data sets, which first is MNIST, which is used as the reference database for artificial neural networks training of testing of that, and the other one is we have the ready database of the cancer database, the cancer data. So we're gonna determine the strength and weaknesses of TensorFlow and PyTorch in terms of ease of use, computational efficiency, and the how flexibility they are offering. And to identify which framework is better suited for the specific problem or task, we will determine that also. So here are some when it comes to the comparison, we have we have to do some criteria. So these are the criteria. First one is model architecture. Like we have to compare the neural network architecture, like how it's structure the model for in TensorFlow and the PyTorch, which includes the number of layers, which are the activation functions we're gonna use, and what are the loss function we will use. And second one is performance matrix, which will give us the accuracy and the mean square error such like parameters. Then third one is training time and the efficiency. We will compare how long it take a runtime to train the model, and the ease of use. We will compare the what is the easy way to use the temperature, the TensorFlow and PyTorch. So including these factors, such factors that is documentation, user interface, and programming language support. So we'll discuss that.
Hi, so I worked on the cancer datasets to compare these two libraries, the TensorFlow and the PyTorch library. And in order to make sure that I'm comparing apples to apples, I made sure that the the neural network architecture are essentially the same. So for both models, there were 5 layers created. There was an input layer, which is a linear input layer. There was an activation layer. There was also a normalization layer, which is a batch, which was a batch normalization layer. There was a dropout layer, as well as a linear model layer. Part of the parameters that were selected for both models were the number of epochs as well as the batch size, which were equal, and also the activation function or the loss function that were used for both models was the stochastic gradient descent function. And so the output or the parameters that we identified to as a comparison for both of them included, like Vandana said earlier, the average time of execution. So for PyTorch library, there was an average time of 1.8 seconds, and for TensorFlow, there was 3.65 seconds. For the PyTorch library, there was the accuracy of 92%, and TensorFlow had 90%. For PyTorch, there was also a loss of about 28%, and for cancer, there was a loss of about 22%.
Moving on with the comparison, we also subjected the two TensorFlow and PyTorch um, to mixed data. So mixed data is actually an image data which we found on the on one of the data's database. So what we also did to them was to subject both PyTorch and TensorFlow to the same conditions. So we were able to look at um, based on the epoch. So the epoch that's basically the value of loss function after a number of iterations. So we subject them to about 50 iterations. So after every 10 iterations, we took the value of the loss and then the accuracy. So what the accuracy did for us is just to be able to predict the correct output for every given input, and also the loss. What the loss help us do is that we help us see if our prediction is closer the to the target value. So for TensorFlow, for TensorFlow, the average time taken was 12.35 seconds, and the accuracy is 90%. And for the average loss, for average loss function, is we have 0.39. And on trying to run the PyTorch, it obviously took it took time for 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 the average time, because it took us about 394.38 seconds, but the is accuracy is also 72%, and the average loss function for PyTorch under the minis data is 1.59.
Hi, my name is John Daniel. So continuing from where my partner stopped, one of the things we also did to ensure that we had a fair comparison between our PyTorch model and our TensorFlow model was that we restarted our system each time we ran the model, and then we did a comparison. We ran the model three times for each model with each library. So we did had a total of 12 runs for all our models, and we took the average value of this because of various conditions that were inside. And after this, we also noticed that the minutes data set, when using PyTorch, it took longer time for the PyTorch to build a model that could properly function. And even after the longer time that it took, the average accuracy was still low compared to the TensorFlow. I think this might be because it's an image data set. But on the other hand, when we tried that for the cancer data set, which was a CSV file, we noticed that the PyTorch actually did very well, and it did better than the TensorFlow model. It took lesser time, and it had a higher accuracy. Although the loss functions were almost the same, were almost on the same plane, but the PyTorch model really did well with the CSV file in comparison to how it performed when we gave it an image file. Then another thing again that we also noticed was that the the PyTorch model was a bit complicated. It was very long in comparison to what the TensorFlow model looked like. TensorFlow model was brief. It was straight to the point. The PyTorch model, on the other hand, had a lot of functions, a lot of lines of code that we had to run to make it work properly. And so these were some of the things that we noticed when we were in the course of this project. And I think that is pretty much it. And this is the end of project 3 for group 2. Thank you. For group 1, sorry. Group 1, I mean.